All right, we are moving into section 4.3, and we're going to split it into 2 days as well, because there's a lot crammed into some of these matrix lessons. So for day 1, first of all, let's look at all the objectives. We have determine the dimensions of the product of 2 given matrices, multiply 2 matrices, and represent a system of equations using a matrix operation. We're going to focus on the first 2 objectives here for day 1. Okay, so just those first 2. So first up, multiplication of matrices is defined only if, that's important, the number of columns in the first matrix is equal to the number of rows in the second matrix. So I have a couple examples here for you. So in example 1, okay, notice that we have our 2 matrices, okay, that are being multiplied together. This first one is a 2 by 2 matrix. We have 2 rows, 2 columns. The next one is a 2 by 3 matrix. So we have 2 rows, 3 columns. Okay, so these right here are the dimensions. So 2 by 2 times a 2 by 3. According to this, in order to multiply them, the number of columns, so that's the second number right here, in the first matrix has to be equal to the number of rows in the second matrix. Okay, so that's why it says those 2 numbers have to be the same. Oftentimes, like that's a very simple way to check if you can even multiply your matrices. So you can multiply these. Okay, so same here in example 2. In this example, we have a matrix that's a 3 rows by 2 columns, a 3 by 2, multiplied by a 2 column and 1 row, or 2 row, pardon me, and 1 column matrix, or a 2 by 1. But again, the numbers on the inside here are the same, so you can multiply those. If they are not the same, if they are not equal, you cannot multiply the matrices. So this last column is an example of that. So if you have matrix A times matrix B, and matrix A is m times n are the dimensions there, and matrix B's dimensions are n times p. As long as these 2 numbers in the middle are equal, you can multiply them. The other cool part about this, we hadn't brought up yet, is that the numbers on the outside, so this m and this number here, they will make the dimensions of your product, so of the matrix A times B. So that will be an m times p will be the dimensions of your new matrix. So that may not make sense just yet. That's always how it goes, right? Like it doesn't always make sense at the beginning, but we're going to make it make sense. So there's some really cool things, and that's why it's so important, and we spent some time just focusing on the dimensions of your matrices. So let's look at example 1. Determine the dimensions of each defined matrix product. Okay, so we want to determine the dimensions of the matrix product. If the product is not defined, you can state so. All right, so what this means, let's get started. We need to first see, so like in A, we're multiplying A times B. Well, we need to see if we can even do that. Okay, so let's go through here. A, what are the dimensions of A? Well, it's 2 rows and it's 2 columns. So this is a 2 by 2 matrix. B, let's look at it. Has 2 rows by 1, 2, 3 columns. And matrix C has 3 rows by 3 columns. Okay, so that's going to be the first step to help us. So can we do A times B? So we're going to have a 2 by 2 times a 2 by 3 matrix. All right, so are these 2 numbers the same? Yeah, they are, so we can multiply it. If we multiply it, that means our product, okay, those numbers on the outside are going to be the product dimensions. Dimensions. So our matrix product is going to be a 2 by 3. Okay, so AB will be a 2 by 3 matrix. Well, and maybe we want to put AB equals a 2 by 3 matrix. Okay, let's try B. Okay, so we want to multiply A times C. So A is the 2 by 2 times C, a 3 by 3. Oh, that's a parentheses. So remember, we got to check these two interior numbers. Are they the same? That's their question. No, they are not. So they are not the same. So can we do this one? Nope. This one is undefined. Okay, the product matrix is undefined. In C, we're going to multiply B times C. So we're going to have a 2 by 3 matrix times a 3 by 3 matrix. Are our inside products numbers the same? Yes, right, they're the same. So our product dimensions are a 2 by 3. Okay, so BC is going to equal a 2 by 3 matrix. You could say. However you want to write that in there is fine. Awesome. And let's look at D. We're multiplying B times A. Okay, so B is a 2 by 3 times A, which is a 2 by 2 matrix. So we check these inside numbers. Are they the same? Nope, not the same. So what's the product matrix? Undefined again. Right, because we can't do it. Awesome. So you have to check that with every matrix multiplication. You have to check to see if you can even do it. All right. Then let's look at how we multiply two matrices. So to multiply two matrices, we're going to multiply the elements of each row. So multiply the elements of each row of the left matrix by the corresponding elements of each column. Now wait a minute. Row to column of the right matrix. And it says, then sum the products. Find the sum of the products. It's like, what are you talking about? Are you kidding me? So I've got three different things here to help show you what's happening. Okay, to help us sort it out a little bit. So first of all, we're going to take the elements of each row. So we're going to take A and B, and we're going to multiply them by the corresponding elements of each column in the next one. So EG. So you will notice that it's like this one just comes over and drives right in and parks. So then B would be beside G and A would be beside E here, which is why, okay, so we have AE, A times E, plus BG, plus B times G. And we're going to add those together. I know that's real tricky, right? Let's look at the next row. Okay, so for the next one, we still have the first row here. Now we need to move over to the second column. So we have A times F plus the B times H. That goes here. So this is the trickiest part. This is different from scalar multiplication. This is matrix, multiplying two matrices together. Okay. All right, so we can keep following this pattern. Then we're done with the first row because we did the first row times column 1, the first row times column 2. Now we need to do the second row times column 1. So CE plus D times G. Once we get that down, we do the second column times the second row, pardon me, times the second column. So we have CF plus D times H. Okay, so lots of stuff going on there. Now, if you want to see, we can walk through it a little bit from the whole thing here, right? So we've checked, we have a 2 by 3 matrix times a 3 by 1 matrix. We checked like, okay, these are both a 3, and that, so we can multiply. This is a 2 by 1. That tells me how many dimensions I'm going to have in my solution. So you notice down here, I end up with just a 2 by 1. Sometimes it's easier to see how to do in a smaller matrix. So I'm going to take this one, okay, this column, and I'm going to multiply this row. I'm going to multiply it by this column, 7, 8, 9. So I do 1 times 7, 2 times 8, 2 times 8, 3 times 9. But notice they're all being added together after I find their products. Then I'm going to take my second row and multiply it by this one column. So I have 4 times 7 plus 5 times 8 plus 6 times 9. Okay, have to add all of those together. So first I did the multiplication. I still need to go back and do the addition. When I do the addition, I have 50 over 122. So I end up with that 2 by 1 matrix. In the last example, it's a this one is a 2 by 3 matrix times a 3 by 2 matrix. So our inner numbers, right, are a match. Our product should be a 2 by 2 matrix. Sure enough, we have a 2 by 2 matrix here. And it walks you through every step just like the other one did. So you can go back and reference these if you get stuck. You have 1 times 10 right here, and then 2 times 20 right here, 3 times 30 right here. Then you're going to move over to your second column, 1 times 10, or sorry, 1 times 11, 2 times 21, 3 times 31, okay? So it's kind of a tricky way to solve it, but again, this is actually a shortcut for solving systems of equations. Okay, so we're talking systems that would have multiple variables in them. So instead of doing all the work to solve all of these systems with, so these two systems with 8 variables, okay, we're doing a matrix to solve. Okay. All right, so let's flip over to the back and try to do a couple of these. So example 2 says find AB when A equals 240, 135, okay, and B equals 345210, and then we're going to find BA. All right, so we want to do AB first. Well, first of all, A, let's look at its dimensions, is a 2 by 3, and we're multiplying it by B, which is a 3 by 2. Okay, so are the innermost numbers the same? Yes, so we can multiply, which means we're going to end up with a 2 by 2 product. Okay, this is helpful to know. Okay, so let's get to work. We're going to have a 2 by 2 product, but we're going to have to set it up and leave ourselves some space to show our work. Okay, so we're going to take this row multiplied by this column. Remember, it's kind of like this one is going to pull in, it's going to like just drive in right here. So the 0 is going to match up with the 1. The 4 is going to match up with the 5. And the 2 is going to match up with the 3. So this is going to be 2 times 3 plus 4 times 5 plus 0 times 1 for that first one. Okay, then we're going to take this same first row, multiply it by this second column, and it's going to do the same thing. It's going to pull in here, drive right in there. So for this next number, okay, we're going to have 2 times 4 plus 4 is going to match up with 2. So 4 times 2 plus, and our last one, 0 times 0. Okay, then we're going to do our bottom row and our first column, and it's going to pull right in there. Okay, so we're going to have 1 times 3 plus, the second number is 3 and 5, so 3 times 5 plus the last number, 5, that is a 5, right? Yeah, I've colored over it, so 5 times 1. Okay, and our last one. So our last one is, we're going to stick with that second row, and we're going to go over to our second column, drive it right over beside it. Okay, so the first number in each one, 1 times 4, plus the second number in each one, 3 times 2, plus, and the third number in each one, 5 times 0. And let me close our matrix. Notice we are going to end up, we made it with a 2 by 2 matrix. We have 2 rows and we have 2 columns. We just have to do the rest of the work. Now hopefully you notice some patterns too between these numbers. Like if I look this way, I notice that the first number, it's always 2 times a number, 4 times, you know, here, 2 times 4, 2 times 3, and then 4 times a number, 4 times a number, 0 times a number, 0 times a number. And then you should notice if you look down the column, the number in parentheses are the same. So I'm not multiplying something by 3, something by 5, multiplying by 1. Here I'm multiplying by 4, by 2, by 0. You can do those checks. That'll help you know if you set them up correctly. Okay, so let's do the next step here. So let's do the, I left enough room. We could even show it here. It just kind of depends on what you want to do. So let me show it here. Maybe that'll actually help. So 2 times 3 is 6, plus 4 times 5 is 20, plus 0 times 1 is 0. Right, so we're just going to do that math and then we add it. 6 plus 20 plus 0 is 26. So that's the first number in our matrix in the final answer. Okay, then 2 times 4 is 8, plus 4 times 2 is 8, plus 0, so that's 16. So our second number is 16. Here, 1 times 3 is 3, plus 3 times 5 is 15, plus 5 times 1 is 5. So 5 plus 15 is 20, plus 3 is 23. So that's the second row, first column number. Okay, and then our last one, let's see, is red. 1 times 4 is 4, plus 3 times 2 is 6, plus 5 times 0 is 0, 4 plus 6 is 10. So on our second row, second column, we have a 10. So this is our final matrix. This is AB. I'll put that in there. So AB equals 26, 16, 23, 10. All right, let's see if we can cram BA in here. Okay, so again, let me erase all this stuff here. So again, what I started to say was let's check the dimensions, right? We always need to do that. So B is a 3-row, 2-column. So 3 by 2 times A, which is a 2 by 3. So 2 by 3 matrix. Right, so we've got a 3 by 2 times a 2 by 3. All right, so our middle number is the same? Yes. And so that means we're going to have a 3 by 3 product. Okay. When we did A times B, we had a 2 by 2 product. Now that we're doing B times A, we're going to end up with a 3 by 3 product. Okay, so let me make my bracket here a little longer, maybe a little wider. We'll have to see how it comes out. Okay, so let's get started. This time we're doing B times A. So might be helpful if we, let's see, rewrote it. I'm just going to cram it in here. So 2, 4, 0, 3, 5. Okay, hope I don't have to erase. Okay, so we're going to start with our 3 times 4 here. So in the first one, in our first spot, we're going to have 3 times 2 plus 4 times 1. Okay, then we're going to move to the second column. So 3 times 4 plus 4 times 3. And then on to our third column. 3 times 0 plus, I'm really cramming it, 4 times 5. I'll write it underneath here. I have to write a little smaller. Okay, then let me go back to purple. Maybe I should have done all those in purple. All right, then we're going to focus on the second row here. So we've got 5, and we're going to do the first column. So 5 times 2 plus 2 times 1. And then we're going to go to the second column. So 5 times 4 plus 2 times 3. All right, and then on to our third column again. 5 times 0 plus 2 times 5. Okay, and then we're on to our third column. So we're doing our third column, or third row by our first column. So 1 times 2 plus 0 times 1. Okay, so hopefully you're noticing this pattern, like, okay, I've got a 2 in the parentheses here for everyone, a 1 in the parentheses here. I'm doing good. Okay, so for our next, we're going to move on over to the second column. 1 times 4 plus 0 times 3. And then on to our third column. 1 times 0 plus 0 times 5. Okay, so if you're checking, again, looking for those patterns, if you look across, it's always 3 and 4, 3 and 4, 3 and 4. Here it's a 5 times a number and a 2 times a number. So 5 times, 2 times, 5 times, 2 times. On the third row, it's 1 times and 0 times. So 1 times 4, 0 times something. 1 times plus 0 times. So those patterns are helpful. Okay, so let's go through and do our math. 3 times 2 is 6, plus 4 times 1 is 4. 6 plus 4 is 10. So my number there is 10. And you can do this in any order. You could go across and do the math. You could go down and do the math. It does not matter. 3 times 4 is 12, plus 4 times 3 is 12. So this is 24. 3 times 0 is 0, plus 4 times 5 is 20. So this is 20. There is my first row. Okay. Second row, 5 times 2 is 10, plus 2 times 1 is 2. So I've got 12. 5 times 4 is 20, plus 2 times 3, which is 6. So 26. 5 times 0 is 0, plus 2 times 5 is 10, so 10. Row 2 is done. Last row, 1 times 2 is 2, plus 0 times 1 is 0, so 2. 1 times 4 is 4, 0 times 3 is 3, 4 plus 3 is 7. And 1 times 0 is 0, plus 0 times 5 is 0, so we have a 0. So there we have B times A. And it is indeed a 3 by 3 matrix. So knowing the dimensions of your product is super helpful. Okay, we're going to skip this question, is matrix multiplication commutative? Because you cannot, well, I want to, like, it should be on your notes maybe a little bit more tomorrow. But the answer is no, so I won't skip it. The answer is no. Matrix multiplication is not commutative. This is not a good example of that because we were able to do A times B and B times A. Would have been better to have that question after example 1, where we noticed we couldn't multiply in any order. So that's a kind of a terrible place for it. I apologize, but sometimes that's what happens when I follow the order of the textbook and doing things. I don't always like it. All right, so let's look at example 3. Should say use, not us, use of the football data given. Okay, and it's really hard to see that football data on my screen, so I've got the book with me. It's easier to see on your paper, but I don't feel like a lot easier. So anyway, we want to create T 3 by 4, so matrix T, which is a 3 by 4, representing the team's scoring data, and V, which is a 4 by 1, representing the point value data. Then B, we're going to find the product of the matrices and state what the data in the matrix product represents. Okay, so first of all, let's start with matrix T. All right, we want it to be a 3 by 4, so it's going to be a pretty good little size matrix here. This is A. All right, so notice it's a 3 by 4 because we have 3 rows and 4 columns. So we're just taking the numbers and pulling them right out of this chart, out of this table here. Okay, so the numbers we're going to pull out are 2, 2, 2, 0. That's that first row. In the second row, we have 0, 3, 2, 1. And make sure you're lining these up really well so you can tell what goes where. In the third row, we have 3, 4, 4, 0. Done. Okay, and then we're going to do V, okay, which represents the point value data. That's this section. It's a 4 by 1 because we have, as I covered it up in my circle, we have 4 rows and 1 column. Okay, so that's what it's going to be. It's going to be tall, skinny. So in the first row, we have 3, second row 6, third row 1, and fourth row 2. That's it for A. Pretty simple. Let's look at B. Okay, B wants us to find the product of the matrices and state the data in the matrix. Okay, so it doesn't say which product, so I guess we'll do T times V, and then we could look at V times T even. Should have been more specific, I guess. Okay, so let's look at these. T, we know, is a 3 by 4 matrix, and we want to multiply it by V, which is a 4 by 1 matrix. So check our inner numbers. Are those equal? Yes. So then we're going to get a product of a 3 by 1. Okay. Okay, so let's do this. So we're going to get a 3 by 1. Oh, nice. So TV is going to equal, it's going to be 3 rows and just the 1 column. pretty sweet gig. Okay, so, because remember, we're taking all of these numbers and multiplying them. So let's do this first row, okay, by the whole column. So the first number in each one, we have 2 times 3. So we got 2 times 3 plus 2 times 6 plus 2 times 1 plus 0 times 2. All right. Second number, or second row, I should say. All right, so we're going to take these, multiply each element to here. So 0 times 3 plus 3 times 6 plus 2 times 1 plus 1 times 2. Okay, and then our last row, okay, times our column. So 3 times 3 plus 4 times 6 plus 4 times 1 plus 0 times 2. Okay. Again, you can check, like, all the numbers in the parentheses down are 3, 6, 1, 2. Okay, those are the same numbers in the column, 3, 6, 1, 2. So recognizing these patterns helps you see what's going on. Okay, so let's do the math. So TV is going to equal 2 times 3 is 6, plus 2 times 6 is 12, plus 2 times 1 is 2, plus 0 times 2 is 0. So 6 plus 12 is 18, plus 2 is 20. All right, let's go to the next row. 0 times 3 is 0, plus 3 times 6 is 18, plus 2 times 1 is 2, plus 1 times 2 is 2. So 0 plus 18 is 18, plus 2 is 20, plus 2 is 22. And our third row. 3 times 3 is 9, plus 4 times 6 is 10, plus 4 times 1 is 4, plus 0 times 2 is 0. So 9 plus 10 is 19, plus 4 is 23. Did I do something wrong? 3 times 3 is 9. Okay, my answer key says it's 37. Did I do something wrong? Oh, 4 times 6. Where did I get 10? Is 24. My goodness. I knew something was off. Okay, so 9 plus 24 is 33, plus 4 is 37. All right, so TV is here. Oh my goodness. All right, so I said we'd do VT next. So I guess maybe you have some room on yours. I'm going to have to erase here so we can look at VT, the product of VT. Okay, so let's look at VT. All right, so V is the 4 by 1 times T, which is a 3 by 4. Okay, check our inner numbers. Ooh, these are not the same. Thank goodness. This is undefined, if I could spell. There is no more work to do here, right? We cannot do VT, which again shows that matrices are not commutative. Multiplying matrices is not commutative, which means we cannot multiply in any order. We must check. All right. I know. Could you imagine if we did all of this section today, 4.3? Like today's lesson's 34 minutes. So you'd be watching for like an hour. Anyway, that's it for today. Have a great night. See you tomorrow.